In the movie Fast Five, they pull off a heist when being able to pull a vault with two quote unquote muscle cars. I thought, okay, maybe with two. But in the scene, it can be seen that in the world of Fast and Furious, only one car is needed. Which had me wondering, can that car pull the vault in real life? The two main formulas I'm going to have to use to tell whether or not this is real is the point slope formula, which is y2 minus y1 over x2 minus x1, which is exactly acceleration equals the average velocity over the average time. Another formula we're going to have to use is the classic physics formula, force equals mass times acceleration. So in this scene, the car they use is the Dodge Charger SRTA 2010, which according to research has an acceleration of 0 to 60 miles per hour in 9.3 seconds. In order to find the answer to this equation, we must find the acceleration of the car in seconds. How many seconds are there in an hour? There are 3,600 seconds in an hour. So in order to find the answer, we must divide 60 by 3,600, and we get 0.016 miles per second in 9.3 seconds. Now that we have both the velocity and the time, we have what it takes to find the acceleration of the car, which would have to be the average velocity over average time. In order to get that, we need to subtract the final velocity minus the initial velocity over the final time and the initial time. Now, before we use the equation of acceleration times mass equals force, we have to convert the miles of the equation into meters. So when converted, 0.0017 equals 2.7 meters per second. Now that we have both meters and kilograms, we can get the force in newtons, which would be 5,170.24 newtons. We now know the force of the car that it has to offer, but how much force does it take to actually move the boat? In order to find that, we have to use the same equation, mass times acceleration equals the force. And here we would use 9.8, the gravitational acceleration of Earth, times the mass of the boat. How did we get 9,100 kilograms? In the movie, before they actually pull off the heist, they mentioned that the boat is 10 tons of top-of-the-line security. Now 10 tons is equal to 9,100 kilograms, which is how we found the weight for our mass. So now that we have both the acceleration and the mass of the boat, we can now find the force. So when multiplied, we get 89,278 newtons of force, which is not nearly as close as what you really need. I decided to calculate the acceleration the car would need in order to actually pull the boat. So what we did is we got the newtons of force that the boat had and added 1. It's not 78 anymore, but actually 79, because if it was equal to 78, that would mean it would still not be able to pull it. So we raised it by 1, and then we also got the mass of the car, and we have acceleration to find. So we divided 89,279 by 1,886.95 and got 47.31 meters per second, which is nowhere near 2.4 meters per second, which is what the car had since the beginning. So in the end, no, it is not realistic.